Hello students, we will discuss the most important topic is relationship between line and phase values and expression for power for balanced delta connection. Okay, you can see this figure. This is the delta connection load where you have this RYP. So if you observe this point, the starting winding of the starting coil, the starting first coil, the starting end is connected to the finishing end of the another coil. Okay, here the finishing end is connected to the starting end of another coil. Hope you understand this point. Clear? Now, now, so now let us assume the current directions here. Since it is a clockwise direction, R to Y, R is connected to R to Y and Y to B. RYB phase sequence we are taking now. RYB phase sequence. So this is the current flowing to the IR and this is the current flowing to the IY and this is the current flowing to the IB. Okay. So from Y to R, from RY, yes or no? R to Y, Y to B. So current will be flowing from RY or IYR. So IYR, there is some current here. IYR, R to Y, Y to R will be same. Next, Y to B or B to Y. B to Y will be another current here. Next, R to B, RY, YB, and BR. From BR, from R to B, we get one more current here. IRB. Current which is flowing from R to B. Okay. So this is the point you have to remember here. Okay. Now let us consider the delta. Let us apply the KCL at. Let us apply KCL. Let us apply KCL at this point. Okay. If you apply KCL at R, apply KCL at R. What we get here? Apply KCL at R means, so from this R, IR is leaving is equal to IR is leaving. Then what is the incoming current we have here? IYR minus the leaving current is what? Leaving current is always minus IRB. Okay, this can also be written as IYR plus of minus IRB. So this is IR. Okay, now let us find this. So this is nothing but the connection diagram. So this is the connection diagram. Okay, this is the connection diagram. Now let us find the vector diagram. Okay. So how to find this vector diagram means, okay. So let us name this as the phase voltages. This is R, Y, B. Phase sequence is R, Y, B. Okay, this is R to Y. This is Y to B, and this is B to R. Okay, we can see no. The first letter will be the sequence here. The first letter indicates the sequence. R. Next Y. Next will be B. Hope you understand this point. Okay. Now another point here is so from this we have okay, this is nothing but the corresponding voltage. For the corresponding voltage, okay, for this corresponding voltage VRY, we get VRY. For that we get corresponding IRY current. Okay, IRY current. So the angle between this will be, always remember, phi. Always remember phi. Yes or no? The cosine of the angle between the voltage and current is nothing but the power factor angle. In the same way, you also draw the corresponding current for the YB phase also. So this will be IYB, IYB or IBY. Anything will be same. IYB or IBY. Okay. So let us name this one as the IYB or IRY or IYR. So let us name this as IYR. Okay, let us name this as what? IBY. For the sake of understanding, that's it. Also, you draw another line which is lagging for the voltage. Okay, so this is the current for IBR, IBR. So the angle here is always phi. So the angle here is always phi. Always remember I lags V by an angle of phi. You have to remember this point very carefully. Okay. Now, according to the statement, according to the KCL point, what we have just discussed here is, what is IR? IR is nothing but, you have to remember this formula. Means you have to okay. Okay, we will be using now this formula, this condition. IR is equal to what? I by R plus of minus IRB. Now, what is the I by R we have? I by R. Yes, we have I by R. But do we have any minus of IRB? No. No, we don't have any minus of IRB. But we have this plus of IBR. If I draw an exact mirror image, okay, this is nothing but minus IBR or IRB. Minus IBR or IRB. Okay. Now, how do we join these two? Because this is the addition, vector addition. So how to find vector addition? As I said already, parallelogram law of addition of vectors. You can find this. Okay. How do we find this? Just draw the same line. Draw the same line. The resultant will be this one. Draw the same parallel line. Draw the line which is parallel to minus IBR, and also draw the same line parallel to. So this is the resultant now. Okay, this is nothing but now IR. In the same way, also draw the another case also. Okay, if you want to find this, if I have a find at this at R, you can also find the value at Y also. Okay, at this point, at Y, KCL at Y. If you apply KCL at Y, what we get here? KCL at Y, KCL, KCL at Y. Then what we get here? Then IY is equal to what are the incoming and what are the leaving currents? Yes, please. IY is equal to incoming currents is incoming currents is IBY 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 minus IYR IYR. Okay, IBY minus. So if you simplify that the same way, IBR minus IYB.